May 6, 1890, Elizabethport, New Jersey. The engineering blueprints scattered across Frederick Bourne's desk would never adequately explain what happened when fire consumed Singer's massive factory that night. Through the smoke and twisted steel of what had been America's most productive sewing machine facility, European competitors celebrated what they called proof of American manufacturing's fundamental weakness. Fast production, they said, but no lasting precision, no true quality, no engineering discipline that could withstand real disaster. For decades, European craftsmen had dismissed Singer's methods as crude American improvisation, machines that worked, but barely, held together by hand-fitting and hope rather than genuine precision. Yet, in the ashes of that 800-foot factory lay something the Europeans had never seen. Components machined to tolerances they considered impossible. Steel gears cut with accuracy that exceeded their finest guild workshops. Parts so perfectly manufactured they could interchange between machines built years apart. The fire had revealed Singer's secret. Beneath the appearance of rough American speed lay precision manufacturing that surpassed anything Europe had achieved. Standing in those smoking ruins, Bourne made a declaration that would prove European engineering wisdom completely wrong, not by building faster, not by cutting costs, but by achieving something European masters claimed Americans could never master: perfect, interchangeable precision at massive scale. Frederick Gilbert Bourne strode through the cavernous Singer Manufacturing Company facility in Elizabethport, New Jersey, on a crisp October morning in 1889, his polished leather boots echoing against the cast-iron floor plates. The sound should have been swallowed by the thunderous noise of 13,000 sewing machines operating at full capacity. But something was wrong. Each machine sang a slightly different tune, a mechanical cacophony that revealed the truth Bourne had suspected since assuming control of the world's largest sewing machine manufacturer 3 months earlier. He stopped beside machine number 4273, watching master assembler Heinrich Müller perform his morning ritual. Müller withdrew a small brass-numbered tag from his vest pocket, consulted his leather-bound notebook, then selected specific gears, springs, and shuttle components from individually marked wooden bins. Each part bore its own serial number, hand-etched during manufacture. Muller's weathered hands moved with the precision of a Swiss clockmaker, filing edges, adjusting tensions, and fitting components that had been manufactured specifically for this single machine. "How long to complete assembly?" Bourne asked, though he already knew the answer from weeks of observation. Muller glanced up, wiping metal shavings from his fingers. 6 hours for this model, sir. Maybe 7 if the shuttle housing needs additional fitting." He held up a brass gear wheel, squinting at its teeth in the gaslight. "This one's running tight. Need to hand file the engagement surfaces." Bourne nodded and continued his inspection, but his mind was calculating disaster. Singer produced more sewing machines than Wheeler Wilson, Howe, Grover Baker, and every European manufacturer combined, over 250,000 annually from their Elizabethport factory alone. Yet every single machine required individual hand-fitting by master craftsmen using 18th century gunsmithing methods. If Muller's machine 4273 broke down in rural Kansas, its owner couldn't simply order gear number 27 from Singer's catalog. The replacement part had to be hand-fitted by a traveling mechanic, assuming one could be found within 500 miles. The irony burned deeper when Bourne considered Singer's global reputation. European engineering publications dismissed American manufacturing as quantity over precision, fast but fundamentally imprecise methods that prioritized profit over craftsmanship. Yet Singer's own factories proved their criticism correct. Each machine was essentially a custom creation, assembled by individual craftsmen using methods that hadn't evolved since Revolutionary War gunsmiths. Walking past rows of hand-operated lathes where skilled machinists shaped each component to approximate specifications, Bourne recalled his recent correspondence with Charles Wheeler of Wheeler Wilson Manufacturing. Wheeler's smaller company had achieved something that seemed impossible: true interchangeable parts using what they called armory practice. Every component manufactured to precise tolerances using gauges, jigs, and inspection methods developed at government armories. Their New Haven factory produced 25,000 machines annually, but any gear from any machine could be installed in any other machine without modification. The technical implications staggered Bourne. Wheeler Wilson had mastered precision manufacturing that Singer, despite producing 10 times more machines, had never attempted. When Wheeler Wilson customers needed repairs, they simply ordered standard parts from printed catalogs. Installation required no special skills, no hand fitting, no master craftsman. Their service network spanned the continent using ordinary mechanics and mail-order replacement parts. Standing in Singer's shipping department, Bourne watched workers crate machines destined for markets spanning 5 continents. Singer dominated global sales through aggressive marketing and installment payment plans, but their manufacturing methods remained trapped in pre-industrial craft traditions. European competitors like Hengstenberg, Brothers in Germany, and Hertu in France produced fewer machines but achieved superior precision using guild-trained craftsmen and centuries-old manufacturing wisdom. The shipping records told a sobering story. Singer machines frequently required extensive service calls within their first year of operation, not due to design flaws, but because hand-fitted components loosened, wore unevenly, or failed when exposed to different climates and operating conditions. European manufacturers faced similar problems, but their lower production volumes and regional distribution networks made individual service economically viable. Bourne's engineering background from Cornell University provided the analytical framework to understand Singer's fundamental challenge. Hand-fitting created machines that worked beautifully when new but degraded unpredictably as tolerances shifted. Master craftsmen like Moeller could compensate for manufacturing variations through skilled adjustment, but once machines reached customers, their performance depended entirely on local service quality. In contrast, precision-manufactured machines with true interchangeable parts maintained consistent performance regardless of location or service technician skill. The financial calculations revealed the scope of required transformation. Converting Singer's entire production system to precision manufacturing would demand new machine tools, measuring instruments, worker training, and complete redesign of manufacturing processes. Conservative estimates suggested $500,000 minimum, equivalent to Singer's total annual profits. The board would demand overwhelming justification for such investment, especially when current methods generated reliable dividends. Yet Bourne recognized that Singer's apparent success masked growing vulnerability. Competitors achieving true precision manufacturing could potentially undercut Singer's market dominance through superior reliability and service efficiency. Wheeler Wilson's methods, if scaled to Singer's production volumes, could revolutionize the industry while rendering Singer's craft-based approach obsolete. As afternoon shadows lengthened across the factory floor, Bourne watched Muller complete machine 4273. The finished product gleamed with hand-polished brass fittings and perfectly adjusted tensions, representing 6 hours of skilled craftsmanship. It would sew beautifully for its first owner, but could never be properly serviced using standardized replacement parts. The contradiction that would define Bourne's tenure at Singer crystallized in that moment. America's largest manufacturing company had achieved global dominance using methods that European craftsmen correctly identified as fundamentally imprecise, while smaller competitors had mastered precision techniques that Singer's vast resources had never attempted to implement. The telegram from Edinburgh arrived at Singer's Elizabethport headquarters on November 15, 1889, bearing news that would reshape American manufacturing forever. Robert Whitehill, a Scottish immigrant engineer working from a cramped machine shop in Boston, claimed to have perfected a vibrating shuttle mechanism that could outperform Singer's best models in direct competition. Bourne initially dismissed the message as another inventor's fantasy, but Whitehill's specifications suggested something extraordinary: 900 stitches per minute with perfect tension control across materials ranging from silk to canvas. Within a week, Bourne stood in Whitehill's cluttered workshop, watching a demonstration that challenged everything he understood about sewing machine limitations. The Scotsman's prototype hummed with mechanical precision that made Singer's finest machines sound crude by comparison. Where Singer's oscillating shuttle mechanisms jerked back and forth in angular motions that stressed both thread and fabric, Whitehill's vibrating shuttle moved in smooth elliptical patterns that eliminated the tension variations plaguing conventional designs. The secret lies in the shuttle's path geometry, Whitehill explained, his thick Highland accent barely masking years of careful analysis. Oscillating shuttles reverse direction twice per stitch cycle, creating mechanical shock that breaks threads and damages delicate fabrics. My vibrating shuttle maintains constant motion through a continuous elliptical loop, eliminating directional reversals entirely. Bourne examined the mechanism with growing amazement. Whitehill had machined every component to tolerances that exceeded government armory standards, using precision measuring instruments he had crafted himself. The shuttle housing fit its bearings with clearances measured in thousandths of inches. Gear teeth engaged with mathematical perfection that eliminated the backlash and wear patterns common in hand-fitted mechanisms. Most remarkably, Whitehill had achieved this precision using principles of interchangeable manufacturing that Singer had never attempted. Every component can be reproduced exactly, Whitehill continued, disassembling the shuttle mechanism with practiced efficiency. These gauges ensure that any replacement part will fit any machine without modification. No hand fitting required. The performance demonstration exceeded Whitehill's written claims. His machine sewed silk thread through multiple layers of canvas at 850 stitches per minute without a single broken thread or skipped stitch. Singer's Best Model 12 struggled to maintain 600 stitches per minute on similar materials, and frequently required tension adjustments that interrupted workflow. When Bourne suggested testing leather, a material that destroyed most sewing machines within hours, Whitehill's vibrating shuttle performed flawlessly while maintaining perfect stitch formation. The technical implications staggered Bourne more than the performance improvements. Whitehill had solved the fundamental challenge that limited all existing sewing machine designs, the mechanical stress created by oscillating shuttle systems. By eliminating directional reversals through elliptical motion geometry, the vibrating shuttle reduced mechanical wear by an order of magnitude while enabling consistent performance across all fabric types. More significantly, Whitehill had achieved these improvements using precision manufacturing methods that could be scaled to industrial production. His workshop contained gauges, jigs, and measuring instruments that could reproduce any component to identical specifications. Unlike Singer's craft-based approach, where each machine required individual adjustment by master craftsmen, Whitehill's methods could theoretically produce thousands of identical mechanisms using ordinary machinists following standardized procedures. The business negotiation proved surprisingly straightforward. Whitehill had spent 7 years perfecting his vibrating shuttle design while supporting himself through contract machining work. His patent applications covered not only the shuttle mechanism itself, but the precision manufacturing methods required for production. He understood that scaling his innovation to industrial volumes required Singer's resources, but insisted on retaining rights to his manufacturing processes for potential licensing to other industries. Bourne authorized payment of $8,000 for complete rights to Whitehill's vibrating shuttle patents, along with a consulting contract that would bring the Scottish engineer to Elizabethport as Singer's chief technical advisor. The board questioned the expenditure. $8,000 exceeded the annual salaries of 20 master craftsmen, but Bourne's performance demonstrations convinced even the most conservative directors that Whitehill's innovation could revolutionize their industry. The European reaction proved swift and dismissive. Engineering publications in London, Paris, and Berlin ridiculed Singer's purchase as proof that American manufacturers couldn't develop their own innovations. Americans buying precision from a Scotsman demonstrates their fundamental inability to master sophisticated engineering, declared the Manchester Engineering Review. This expensive acquisition reveals the bankruptcy of colonial technical capabilities. Such criticism stung because it contained uncomfortable truth. American manufacturing had indeed achieved global dominance through aggressive marketing and financial innovation rather than superior engineering. Singer's installment payment plans and extensive sales networks had conquered markets that European manufacturers considered their exclusive domain, but American technical achievements remained suspect among engineering professionals worldwide. James Bolton, Singer's master machinist and factory manager, provided the operational expertise necessary to transform Whitehill's prototype into industrial reality. Bolton had supervised Singer's production systems for over 2 decades, training hundreds of craftsmen in the complex, hand-fitting procedures that current manufacturing required. His skepticism about precision manufacturing reflected practical concerns rather than resistance to change. Gauges and jigs work fine for government armories producing a few hundred rifles annually, Bolton observed during initial planning meetings. We're manufacturing 50,000 sewing machines monthly. Precision methods might work for specialized applications, but mass production requires flexibility that rigid tolerances eliminate. Whitehill responded by demonstrating how precision manufacturing actually increased rather than reduced production flexibility. Interchangeable parts meant that assembly workers didn't require years of training to achieve quality results. Standardized components could be manufactured in large batches using specialized machinery, reducing unit costs below hand-fitting methods. Most importantly, precision manufacturing eliminated the bottlenecks created when master craftsmen were unavailable or overwhelmed by production demands. The transformation began with Whitehill's vibrating shuttle mechanism as the centerpiece of Singer's new Model 15. Bolton supervised installation of precision lathes, milling machines, and measuring instruments capable of achieving tolerances that exceeded European standards. Workers accustomed to hand-fitting methods received intensive training in gauge-based inspection procedures that ensured every component met exact specifications. By spring of 1890, Singer's hybrid production system combined Whitehill's precision, manufactured vibrating shuttles with conventional hand-fitted machine frames, creating products that outperformed all existing competitors while maintaining Singer's traditional manufacturing economics. The transformation reached its crescendo during the summer of 1889, when Singer's Kilbowie factory in Scotland became the proving ground for industrial precision manufacturing on an unprecedented scale. James Bolton stood on the observation platform overlooking 800 feet of production floor, watching 7,000 workers operate in mechanical harmony that would have seemed impossible just months earlier. The factory stretched 3 stories high, its cast iron frame supporting precision machinery that hummed with the rhythmic consistency of a massive clockwork mechanism. Bolton's conversion to precision manufacturing had occurred gradually through months of witnessing results that contradicted his deepest professional assumptions. Workers who had required years of apprenticeship to master hand-fitting techniques now achieved superior quality within weeks using gauge-based inspection methods. Production bottlenecks that had plagued Singer for decades simply disappeared when standardized components eliminated the need for individual craftsman expertise at every assembly station. The gauge and jig system that Bolton perfected represented the culmination of Americans' precision manufacturing innovation. Every component was measured against master models machined to tolerances of 1,000th of an inch, accuracy that European craftsmen had dismissed as theoretically impossible and practically unnecessary. Master gauges verified that gear teeth engaged with mathematical precision, that bearing surfaces maintained exact clearances, and that every shuttle housing accepted its vibrating mechanism without the slightest adjustment. Worker training followed systematic procedures that transformed the nature of manufacturing skill itself. Instead of developing intuitive feel for metalworking through years of apprenticeship, new employees learned to read precision measuring instruments and follow standardized procedures that guaranteed consistent results. Heinrich Müller, the master craftsman who had epitomized Singer's old methods, now supervised teams of workers whose individual output exceeded his previous solo productivity, while maintaining quality standards he could never have achieved through hand-fitting. The Kilbowie factory's production statistics revealed the mathematical beauty of precision manufacturing scaled to industrial volumes. 13,000 sewing machines rolled off the assembly lines weekly, each one identical to specifications that enabled any component to fit any machine regardless of production date or assembly location. Quality control inspectors randomly selected finished machines for complete disassembly, verifying that every component met exact tolerances without exception. Singer's global distribution network suddenly found itself managing a fundamentally different product. Service technicians in remote locations could repair any Singer machine using standardized replacement parts, shipped from central warehouses. The craftsman skills that had made sewing machine repair a specialized profession became unnecessary when precision manufactured components guaranteed perfect fit without modification. Rural customers in Kansas could maintain their machines using the same parts and procedures available in New York or London. The competitive response from European manufacturers revealed their fundamental misunderstanding of American manufacturing evolution. Companies like Hengstenberg Brothers in Germany and Hertu in France increased their marketing efforts while maintaining traditional craft-based production methods, assuming that Singer's precision manufacturing represented a temporary experiment that would eventually prove economically unsustainable. Their engineering publications continued dismissing American methods as crude mass production that sacrificed quality for quantity. This dismissal persisted even as Singer's Model 15 with Whitehill's vibrating shuttle mechanism dominated every objective performance comparison. Independent testing by the Royal Institute of Mechanical Engineers in London confirmed that Singer machines achieved 900 stitches per minute with thread breakage rates 70% lower than the best European competitors. The precision-machined vibrating shuttle handled materials from silk to canvas with identical tension control, eliminating the fabric-specific adjustments that had always limited sewing machine versatility. The technical superiority extended beyond immediate performance to long-term durability characteristics that would define industrial quality for generations. Singer's precision-manufactured steel gears, cut to exact tooth profiles and hardened through controlled heat treatment processes, wore in rather than wearing out during extended operation. The mathematical precision of gear engagement distributed mechanical stress evenly across all contact surfaces, creating bearing patterns that actually improve smoothness over time as microscopic surface irregularities polished away. Bolton's inspection procedures verified these durability claims through accelerated testing that simulated years of normal operation within weeks. Precision-manufactured components maintained their original tolerances far longer than hand-fitted parts, which inevitably developed play and misalignment as individually adjusted surfaces wore according to their unique stress patterns. The interchangeability that enabled easy repair also ensured that replacement components would restore original performance specifications rather than requiring additional adjustment to compensate for accumulated wear. By 1890, Singer's hybrid manufacturing approach had evolved into complete precision production for all critical mechanisms while maintaining economic advantages over purely craft-based methods. The Model 15 incorporated Whitehill's vibrating shuttle within a machine frame manufactured to the same tolerance standards, creating products that European engineers privately acknowledged exceeded anything their traditional methods could achieve. The Elizabethport factory's expansion reflected Singer's commitment to precision manufacturing as the foundation for continued growth. New buildings housed specialized machinery for heat treatment, precision grinding, and final inspection that ensured every component met specifications regardless of production volume fluctuations. The investment in precision tooling and worker training had reached nearly $400,000, but production efficiency gains and reduced service costs more than justified the expenditure. Singer's dominance of global markets became mathematically inevitable, as precision manufacturing advantages compounded through every aspect of business operations. Manufacturing costs decreased as standardized production eliminated the premium wages required for master craftsmen. Service costs plummeted when standardized parts and simplified repair procedures reduced warranty claims by 60%. Most significantly, customer satisfaction improved dramatically when precision-manufactured machines delivered consistent performance that exceeded advertised specifications rather than varying according to individual craftsmen's skill during assembly. The European response grew increasingly desperate as traditional manufacturers faced market share losses that threatened their survival. Guild-trained craftsmen who had represented the pinnacle of mechanical expertise found their skills rendered obsolete by American manufacturing methods that achieved superior results using systematically trained workers following standardized procedures. The Industrial Revolution that had begun with steam power was completing its transformation through precision manufacturing that made human craftsmanship economically and technically irrelevant for mass production applications. Standing on the Kilbowie observation platform in early May of 1890, Bolton surveyed an industrial achievement that exceeded the wildest ambitions of American manufacturing pioneers, unaware that within hours fire would test whether precision manufacturing methods could survive the ultimate challenge of complete destruction and reconstruction. Frederick Bourne received the May production reports in his Elizabethport office with satisfaction that bordered on vindication. Singer Manufacturing had achieved what European critics claimed was impossible: 80% of global sewing machine sales through precision manufacturing methods that delivered superior quality at unprecedented scale. The numbers told a story of industrial triumph that silenced decades of skepticism about American technical capabilities. 275,000 machines shipped during the first quarter of 1890, each one meeting tolerance specifications that exceeded government armory standards. The Elizabethport complex had evolved into a masterpiece of industrial architecture spanning 72 acres along the Arthur Kill Waterway. 3 railroad spurs brought raw materials directly to specialized manufacturing buildings, while steam-powered cranes loaded finished machines onto barges bound for global distribution centers. The main assembly building stretched 800 feet from the administrative offices to the shipping docks, its sawtooth roof design providing optimal natural lighting for precision inspection work throughout the massive production floor. James Bolton's daily production meetings had become exercises in statistical precision rather than the crisis management sessions that had characterized Singer's craft-based era. Workers arrived at standardized stations equipped with gauges, jigs, and measuring instruments that eliminated guesswork from every manufacturing operation. Quality control inspectors randomly selected machines from each production run, completely disassembling them to verify that every component met exact specifications. Rejection rates had fallen to less than 2% compared to 15% under previous hand-fitting methods. The transformation extended beyond manufacturing efficiency to fundamental changes in workforce composition and training. Master craftsmen like Heinrich Müller now supervised teams of 20 workers whose individual productivity exceeded his previous solo output while maintaining quality standards he could never have achieved through traditional methods. New employees completed comprehensive training programs within 6 weeks, learning to operate precision machinery and interpret measuring instruments with accuracy that previously required years of apprenticeship to develop. Singer's global service network reflected the revolutionary implications of true interchangeable manufacturing. Regional warehouses stocked standardized replacement parts that could repair any Singer machine regardless of production date or assembly location. Service technicians in remote territories no longer required master craftsman skills to perform complex repairs, since precision manufactured components guaranteed perfect fit without modification. Customer satisfaction surveys indicated that service response times had improved by 60%, while repair costs decreased by 40%. The competitive landscape revealed the full scope of Singer's achievement as European manufacturers struggled to match American precision manufacturing capabilities. Hengstenberg Brothers in Germany had attempted to implement gauge-based production methods but achieved inconsistent results due to inadequate measuring equipment and insufficient worker training. Their machines still required individual adjustment during assembly, limiting production volumes and maintaining the service complications that Singer's methods had eliminated. Hertu in France responded by emphasizing traditional craftsmanship values in marketing campaigns that portrayed Singer's precision manufacturing as soulless mechanization that sacrificed artisanal quality for commercial efficiency. Their advertisements featured master craftsmen hand-fitting individual components with tools inherited from generations of guild traditions. Sales data indicated that such appeals resonated with luxury markets but failed to compete against Singer's combination of superior performance and competitive pricing. The financial implications of Singer's transformation exceeded even Bourne's optimistic projections. Manufacturing costs per unit had decreased by 35% despite investments in precision tooling and worker training. Warranty claims had fallen to negligible levels as precision manufactured machines consistently outperformed advertised specifications. Most significantly, Singer's market share continued expanding into territories previously dominated by European manufacturers, generating revenue growth that justified every dollar invested in precision manufacturing infrastructure. Robert Whitehill's contributions extended far beyond his original vibrating shuttle innovation as he collaborated with Bolton to develop precision manufacturing methods for every aspect of sewing machine production. His Scottish engineering background provided theoretical foundation for tolerance analysis and quality control procedures that ensured consistent results regardless of production volume fluctuations. The measuring instruments and inspection protocols he designed became industry standards that other American manufacturers struggled to replicate. The Model 15 had evolved into Singer's flagship product, incorporating Whitehill's vibrating shuttle within a machine frame manufactured to identical precision standards. Performance specifications that had seemed revolutionary 18 months earlier now represented baseline capabilities as continuing refinements pushed stitching speeds toward 1,000 per minute while maintaining the reliability that made Singer machines preferred tools for commercial applications ranging from sailmaking to upholstery production. Bourne's final planning meetings for complete transition to precision manufacturing focused on eliminating the last vestiges of hand-fitting methods by year-end 1890. The remaining craft-based operations involved decorative elements and specialized attachments that contributed minimal value to machine performance, but required disproportionate skilled labor investment. Standardizing these components would complete Singer's transformation into the world's first fully precision-manufactured sewing machine company. The evening of May 6th found Bourne reviewing production schedules that projected Singer's capacity would exceed 300,000 machines annually once precision manufacturing methods achieved full implementation. The Kilbowie factory in Scotland was already operating at design capacity, while Elizabethport's expansion would add 50% more production floor space by autumn. European competitors faced the stark choice of massive investment in precision manufacturing infrastructure or accepting permanent relegation to specialty markets that Singer chose not to pursue. At 11:15 that night, James Bolton was completing his routine inspection of the main assembly building when he noticed an unusual glow emanating from the needle-making section beneath the central clock tower. What began as curiosity became alarm as he realized that metal filings accumulated during the day's production had somehow ignited, creating a fire that spread rapidly through the wooden floor structures supporting precision machinery worth over $2 million. Within 30 minutes, flames had engulfed the entire eastern section of the main building. The cast iron structural framework that had seemed permanent and indestructible twisted and collapsed as temperatures exceeded the metal's tolerance limits. Precision lathes, milling machines, and measuring instruments that represented decades of accumulated manufacturing knowledge melted into unrecognizable masses of slag and steel. By dawn, 100 feet of Singer's most advanced production facility had been reduced to smoking ruins that seemed to vindicate every European prediction about the fragility of American industrial methods. Standing in the ash-covered remains of what had been the world's most advanced precision manufacturing facility, Bourne faced a decision that would determine not only Singer's future, but the trajectory of American industrial development for generations to come. Frederick Bourne stood in the smoking wreckage of what had been America's most advanced manufacturing facility, his polished boots crunching through twisted metal and ash that represented $2 million in precision machinery reduced to industrial debris. The acrid smell of burned steel and machine oil hung heavy in the dawn air as he surveyed destruction that European competitors would interpret as vindication of their skepticism about American manufacturing methods. James Bolton approached through the ruins, his face blackened with soot, but his expression resolute rather than defeated. "The fire consumed everything in the eastern section," Bolton reported, his voice hoarse from smoke inhalation. "All the precision lathes, milling machines, and measuring instruments, decades of accumulated tooling knowledge melted into scrap metal." He paused, studying Bourne's reaction. "The board will want to rebuild using our old hand-fitting methods, faster, cheaper, proven successful." Bourne's response would echo through industrial history as the moment American manufacturing chose revolutionary advancement over comfortable regression. "We rebuild with complete precision manufacturing," he declared, his voice carrying conviction that surprised even Bolton. "No hand-fitting, no serial-numbered parts, pure interchangeable production using tolerances that exceed anything we achieved before the fire. The financial commitment he was announcing, $1.2 million, double the original estimate, would either bankrupt Singer or establish American manufacturing supremacy for generations. The board meeting that afternoon tested Bourne's leadership as conservative directors, confronted the staggering cost of his reconstruction vision. Singer's insurance would cover rebuilding using existing methods, but Bourne's precision manufacturing proposal required additional investment that exceeded the company's cash reserves. Director Charles Ransom voiced the consensus skepticism that Bourne had anticipated. We achieved global dominance through practical methods that generated reliable profits. Why risk bankruptcy pursuing theoretical perfection? Bourne's response revealed the strategic thinking that distinguished visionary leaders from competent managers. European competitors celebrate this fire as proof that American methods are fundamentally fragile, he explained, spreading technical drawings across the conference table. They expect us to retreat to hand-fitting methods that confirm their superiority. Instead, we'll demonstrate that American precision manufacturing can achieve results that European craftsmen consider impossible. The technical specifications Bourne outlined with Robert Whitehill's collaboration represented the most ambitious precision manufacturing project in industrial history. New machine tools would incorporate high-speed tool steel that enabled machining of hardened components to tolerances previously achievable only in government armories. Every jig and gauge would be redesigned for complete interchangeability that eliminated even the minimal hand-fitting still required in Singer's hybrid system. Workers would receive comprehensive training in armory practice inspection methods that guaranteed consistent quality regardless of individual skill variations. Partnership with America's leading machine tool innovators transformed Singer's reconstruction into a laboratory for industrial precision that attracted the era's most talented engineers. The Pratt Whitney Company provided precision lathes capable of maintaining tolerances within 0.005 of an inch during extended production runs. Brown Sharp contributed measuring instruments that could detect variations invisible to traditional craftsman techniques. The collaboration created manufacturing capabilities that exceeded anything available in European facilities, still dependent on guild-trained craftsmen and traditional methods. Bolton's operational expertise proved essential for translating theoretical precision into practical manufacturing systems. His experience managing thousands of workers during Singer's transition period provided insights into training procedures that could transform ordinary machinists into precision manufacturing specialists. The systematic approach he developed eliminated the apprenticeship bottlenecks that limited European production while achieving quality standards that surpassed traditional master craftsman capabilities. The reconstruction timeline reflected Bourne's commitment to precision over speed as new buildings incorporated design innovations that supported rather than compromised manufacturing accuracy. Foundations were engineered to eliminate vibrations that could affect precision machinery. Environmental controls maintained consistent temperature and humidity that prevented thermal expansion from compromising tight tolerances. Lighting systems provided uniform illumination that enabled accurate visual inspection throughout the production floor. Worker recruitment attracted machinists eager to master precision manufacturing techniques that represented the future of American industry. Training programs combined theoretical understanding of tolerance analysis with practical experience operating the most advanced machine tools available. Heinrich Müller, who had symbolized Singer's craft-based era, became an enthusiastic advocate for precision methods after witnessing quality improvements that exceeded his highest expectations from traditional techniques. The competitive implications of Singer's reconstruction became apparent as European manufacturers struggled to match American precision manufacturing capabilities without abandoning profitable methods that had sustained them for generations. Hengstenberg brothers attempted to implement precision tooling but achieved inconsistent results due to inadequate worker training and insufficient investment in measuring equipment. Their machines continued requiring individual adjustment that limited production volumes and maintained service complications. By 1895, Singer's rebuilt facility achieved manufacturing precision that vindicated every dollar of Bourne's controversial investment. Components were machined so accurately they could interchange not just within production batches, but across years of manufacturing, creating serviceability standards that competitors couldn't approach. The all-steel construction that replaced mixed materials provided durability that would enable Singer machines to operate smoothly for decades, while modern alternatives failed within years. Quality control procedures verified that precision manufacturing had achieved theoretical perfection in practical application. Random sampling indicated that 98% of all components met exact specifications without any adjustment or modification. The remaining 2% that required correction typically involved operator error rather than systematic manufacturing deficiencies. European engineering publications grudgingly acknowledged that American precision manufacturing had achieved results that their traditional methods couldn't match. Singer's global market dominance became mathematically inevitable as precision manufacturing advantages compounded through every aspect of business operations. 1.3 million machines shipped in 1913 represented the culmination of manufacturing revolution that began in the ashes of the 1890 fire. The precision manufacturing methods pioneered at Elizabethport spread throughout American industry, enabling mass production capabilities that established the United States as the world's manufacturing leader for the remainder of the industrial age. The ultimate validation of Bourne's vision arrived not through immediate sales success, but through product longevity that exceeded all predictions. Singer's Model 27 machines, manufactured using complete precision methods, continued operating smoothly more than 125 years later. Their steel gears polished smooth by use, while maintaining original tolerances that modern manufacturers struggled to achieve using advanced materials and computer-controlled machinery.